So as discussed earlier, so what we have is the current which is 1 by root 2 times the maximum current. That's where we are trying to calculate, correct? So using that we define the sharpness. So see, the current will be nothing but E divided by root of R square plus XL minus XC whole square, correct? Because that's the total current. See, now let's say we have omega 1 and omega 2. So we'll consider any one of them. Let's say we are considering omega 2. Okay. So we have E divided by root of R square plus omega 2L minus 1 by omega 2C whole square is equal to 1 by root 2 times E by R. See, why E by R? Because at resonance the maximum current comes, which is nothing but E by R, correct? So the next becomes, see, we have E and E will get cancelled. So we have root of R square plus omega 2L minus 1 by omega 2C whole square is equal to square root of 2 into R. Now square on both sides. Okay. Now once you square on both the sides, see, you will get R square plus omega 2L minus 1 by omega 2C whole square is equal to 2R square. Now R square, if you shift it to that side, we just end up with omega 2L minus 1 by omega 2C whole square is equal to R square. Now if you take the square root, you will get omega 2L minus 1 over omega 2C is equal to R. Okay, so far you guys are with me. So we are just taking the square root and then we are getting the expression, right? Now what was omega 2? We substituted that as omega naught plus delta omega, correct? So substitute that here. So we will get omega naught plus delta omega into L minus 1 over omega naught plus delta omega into C is equal to R, correct? Okay. So what we have here is omega naught L into 1 plus delta omega by omega naught minus 1 by omega naught C into 1 plus delta omega by omega naught is equal to R. Now let me tell you what we have done. We have just taken omega naught common in that omega naught plus delta omega. Okay. So when you take it as common, you have to divide it, correct? That's how we got the above expression. Okay. So using this, see, we get omega naught L into 1 plus delta omega by omega naught minus omega naught L divided by 1 plus delta omega by omega naught is equal to R. Okay. Now 1 by omega naught C is nothing but omega naught L, because this is at resonance condition, correct? So we are substituting that here. Okay. So far you guys are with me. We just substituted 1 by omega naught C as omega naught L. Okay. So what we have, let's continue the same thing. What we have is omega naught L into 1 plus delta omega by omega naught minus omega naught L into 1 plus delta omega by omega naught to the power of minus 1 is equal to R. Okay. So far understood? See here, see, we have the delta omega by omega naught. That will be a value very less than 1, correct? Very small, correct? So what we can assume and what we can substitute is, in place of that 1 plus delta omega by omega naught to the power of minus 1, we can substitute that as 1 minus delta omega by omega naught. Okay. So the whole expression changes to omega naught L into 1 plus delta omega by omega naught minus omega naught L into 1 minus delta omega by omega naught is equal to R. Okay. So far understood what we are doing? Okay. Now what we get here is omega naught L into 2 delta omega by omega naught is equal to R. Okay. So far understood? So what we have done is, so taking the omega naught L and then that 1 plus delta omega by omega naught and 1 minus delta omega by omega naught, we are getting this expression. Okay. So what we get here is delta omega is equal to R divided by 2 into L. Okay. So By simplifying that, you are going to get this. Therefore, the sharpness of the curve becomes omega naught by 2 delta omega is equal to omega naught L divided by R. Correct? Understood? So, the sharpness of the resonance is also called as quality factor or Q factor. Okay? So, this is called as the quality factor. Understood? So, what we have here is the quality factor. The quality factor can also be represented as the inductive reactance or capacitive reactance divided by the resistance of the LCR circuit. Okay, so this is the whole expression, the mathematical expression for the sharpness of the curve.